In this lesson, we're looking at solving trig equations where there's more inside the trig function than just x or just theta. And for these, we're just going to ask for one value of x. Trying to find all the solutions or the two values over 0 to theta can get more complicated because you're kind of changing the period of the trig function. And so really with these, we're just interested in, can you just find one solution? So we start with this one because usually people can look at this one pretty quickly and see the idea. If we want sine to be 1, well, we know sine of pi over 2 is 1. So what you can see, if you just kind of put pi right there where x was, then the equation would be true. So that means that x has to be pi. The idea is that inside this trig function, you want this x over 2 to be pi over 2. You want what you're taking sine of to equal pi over 2, this thing inside the trig function. So if x over 2 has to be pi over 2, well then that means x is pi. If you really wanted to, you could do a u substitution. You could say, make u equal x over 2, and so you would have sine of u equals 1. And well, we know for sine to be 1, we need to have pi over 2. And so then that means that, again, x over 2 is pi over 2. We get x is pi. So this is going to be the kind of thinking that we're going to be doing on all of these here. You're going to kind of ignore this x over 4 for a second here. You're just going to, again, think about when does sine equal 1? Again, sine equals 1 for pi over 2. So we're thinking we want pi over 2 here. And it's not x that we want to equal pi over 2. It's what's behind my pen right here. Sine of something. That something has to be pi over 2. Well, the something is x over 4. It's x over 4 that has to equal pi over 2. And so then, of course, we can multiply both sides by 4 and do some canceling right there, and we'll get that x has to equal 2 pi. When x is 2 pi, if we plug this back in here, 2 pi divided by 4 is actually pi over 2. So when x is 2 pi, we're actually taking the sign of the angle pi over 2. X is now going to be different from the angle that we're actually taking the sine, cosine, or tangent. And again, if you really wanted to, if it's harder for you to see what's going on here, you could do u substitution. You could say if u equaled x over 4, again, this is optional right here, but if you need help to see it, if u is x over 4, then you could do sine of u equals 1, and then that would tell you that u has to equal pi over 2, and then you would be right back to where we were before. All right, so then on number 3 here, we'll have one extra step to do. So it's important to notice back here, you couldn't multiply by 4 right away. The x over 4 was inside the sine function. It's trapped inside. You can't touch the over 4 right there. This one, this is cosine of 4x, and then plus 1. The plus 1 is outside, so you can go ahead and subtract the 1 over and say cosine of 4x has to equal -1. Again, what you want to do is ignore that 4x for a second. Just think about it, right? We want cosine to be -1. Well, if you want cosine to be -1 on the unit circle, you're looking for the x coordinate to be -1. That's over to the left. So that means we're thinking about pi. It's not x that needs to be pi. It's 4x. What you're taking the cosine of, what's behind my pen right now, has to be pi. So 4x, where the 4x is, I want to be pi. I want the 4x to equal pi. We'll divide by 4, and that tells us x is pi over 4. X is pi over 4, plug it in, and what you're really taking is the cosine of pi. Again, all of these you can do u substitution. After this problem, I'll stop showing it, but I'll show it one more time here. If you made u equal 4x, you could have cosine of u equals -1, and that would tell you that u equals pi, and then from there you would be able to do the rest of this work that we did here. But so over here on this one, we want to divide both sides by the 2, trying to isolate the trig function. It's important to notice, though, when we do this, that the 4x is not going to change. Again, these things are trapped inside those trig functions. You can't touch that 4. And so when I divide by 2, it's just going to cancel that 2. The 4x does not change. So I've got cosine of 4x equals negative root 2 over 2. I'll ignore the 4x for a minute, and I'm thinking, when does cosine equal negative root 2 over 2? Well, root 2 over 2, or you might know it as 1 over root 2, that's got to be some sort of pi over 4. But I want it to be negative, so I have to think about all students take calculus, ASTC. Cosine can be negative for the second or the third quadrant. Again, we're just looking for one answer here, though. We just want the smallest angle. So the angle that has the least rotation here, that's going to be the second quadrant one. And the second quadrant pi over 4 angle will be 3 pi over 4. But that's not the final answer. That's not what x equals. That's what needs to be behind my pen right here. That 4x, what I'm taking the cosine of, needs to be 3 pi over 4. So I've got 4x equals 3 pi over 4. And so then I need to divide both sides by 4. And just make sure you're careful with those complex fractions there. The over 4s don't cancel. You've got 3 pi over 4 divided by 4. Well, that's 3 pi over 4 times 1/4. And so what we get is 3 pi over 16 for our final answer for what x equals. One last one of these here. Again, we do have something outside the function. Make sure you keep straight things inside the function that you can't touch right away, and things outside the function that you do want to get rid of right away. So this one I'm going to do first is multiply both sides by negative 3. And so I'll have tangent of x over 6 equals negative root 3. And I'll ignore the x over 6 for a second, and I want to know, when does tangent equal negative root 3? Well, what you have to realize there is that started as root 3 over 1, and there were some over 2's canceled. So on the unit circle, I had a y of root 3 over 2 and an x of 1/2. And so that's some sort of pi over 3 angle. And that's what x over 6 is going to equal. Not just pi over 3, because I do want it to be negative. Now, if I was doing inverse tangent, I could just stick a negative on this. But we want non-negative angles here. And so I can't just stick a negative on it. I'll think about ASTC. Tangent is negative in the second and fourth. We want the smallest angle. So I'm going to use quadrant 2 again. And so that's going to be 2 pi over 3. And then we'll multiply both sides by 6. Do some cancellation. And my final answer is 4 pi. So then we're going to ask you some problems about trig functions, asking you some different points and values on that function. And you can always just go back and graph the whole function. If you remember your graphs well and you can graph it carefully, then you can answer everything there by doing a careful graph. But now that we've solved these equations, we want to talk about how we can figure out some of that stuff algebraically, and then we'll show what it all looks like on the graph. Right. So the first thing to realize is that the max and min, we have that amplitude on the graph where it bounces back and forth between the same highest y value and lowest y value. And here our amplitude is 2. So we're going to have a max of 2, and our min is going to equal negative 2. That's just from the amplitude of the function. We know the biggest cosine can be is 1, and then multiplied by 2, so the biggest it can be is 2. Now, to find an x value, what I can do is I can just say, well, this is a y value that I just found, the biggest y value. I can substitute that for y, for f of x right there, and solve it. I can see when does the function actually equal 2. So if I divide both sides by 2, I'm looking for when does cosine equal 1. Some of you might even be able to skip that first step and see that the maximum value is going to be when cosine is 1. And so then if I ignore the 5x for a second, I want cosine of something to equal 1. I want cosine to equal 1 on the unit circle. The x-coordinate of 1 is on the right side. So I'm thinking the angle 0. So I want 5x to equal 0, which means x has to equal 0. Then I can do a similar thing for the minimum. But now I'll want 2 cosine 5x to equal negative 2. So I want cosine of 5x to equal negative 1. And so now I should be thinking about the left side of the unit circle. If I want x to be negative 1, I'm over here. So 5x equals pi, and x equals pi over 5. All right, and then for the y-intercept, we know the y-intercept is when x is 0. So I just want to take 0 and plug it into that function right there. So I'm going to have 2 cosine, and then 5 times 0 is 0. So cosine is 0. I know that cosine of 0 is 1. So I'm going to have 2 times 1, which is 2. So I'm looking at a point 0, 2 for my y-intercept, which we probably could have realized already based on what we did in part A. That's the same point that we had there. And then finally for the x-intercept, that's when y is 0. So I'll take 2 cosine 5x, and I'll set it equal to 0. Divide both sides by 2. Cosine 5x is 0. So now if I want the x-coordinate to be 0, I could be thinking about straight up or straight down. I'm looking for the first point, the smallest x value. So I'll look at pi over 2. 5x equals pi over 2. So if I divide both sides by 5, again, you might want to go through writing out the division problem and multiplying by the reciprocal like we did before, but that will give you pi over 10. And so I'm looking at the point pi over 10, 0. And so all that should match what we get if we graph the function. So what we had here, we had a 2 out front, tells us our amplitude. So we've got an amplitude of 2. And then for the period, I always like to just take the inside and set it equal to 2 pi. Some of you might skip right to the step of memorizing the formula of 2 pi divided by that number. So I know the period is 2 pi over 5. And so now if I can put all that together and sketch it carefully, I'll be able to see all of these points here. I know the function is going to bounce between negative 2 and negative 2 for its y values. And then I know that the period is going to end at 2 pi over 5 here. You do have to realize exactly how I can scale that as we do this here. So there's 4 points here. And so what I usually do is I kind of split it in half and then in half again. So halfway to 2 pi over 5 is 1 pi over 5. And then half of pi over 5 is pi over 10. Again, if you need to write that out, 2 pi over 5 divided by 2. Take a minute to figure that out. But you'll get pi over 10. And so then the scale here, we got 1 pi over 10, 2 pi over 10s, and then this would be 3 pi over 10s. And so then remember that cosine starts up at its maximum here. So we've got a point up here, and then got nowhere to go but down, so we have 0, and then the minimum value, and then back up to 0, and then our maximum there. And so the graph looks like this. And so we can see all of these things that we said before. A max of 2, a minimum of negative 2. We can see where those max and min points occur. We can see our y-intercept, and we can see our x-intercept.